this whole class opener is on distributive property, and it's even easier than what we did yesterday, because right here we're just distributing one monomial into a polynomial, right? So on number 1, on this class opener, we have 7 times x, that is 7x, and then 7 times 7, that's positive 49, and we're done, okay? How about number 2? I need to distribute this 5q to each of the terms on the inside of the parentheses. So Layla, what's 5 cubed times 2? You're welcome. Get it? 10q? You're welcome. It's a joke.
No.
Okay, that's not even. She doesn't get it. Explain it to her. Yeah. Yeah.
That sounds much
Okay. 5q times negative 5q, you end up with negative 25q. And that's it. Actually, it is squared. Sorry about that. So once again, 5q times negative 5q, you go 5 times negative 5, that's negative 25, and then the q times q, that's q squared. Are you with me? Okay, so this is all easy stuff that we've learned in the past. Oh man, that's a typo. No, is it a typo? No, it's not a typo. Let's just go with it. We have an 8a right here, Ismail, that we need to multiply by x. So 8a times x, what is that? 8ax. You simply put them together, right? Then you go 8a times negative 7, and what do we get? Negative 56, and what about the a? You just bring it down. So our answer is 8ax minus 56a. Now, of course, after distributing, you're supposed to try and combine like terms, but this is an ax term, and this is just an a term, so you cannot combine those. They're not alike. Number 4, it's a little bit more interesting. We're going to distribute this x into each and every term. So when I distribute the x times 1 is what? X, 1x. You don't even have to put the 1 if you don't want to. Ismail, are you with me? So what's this next answer, Ismail, when I distribute right there? Positive x squared y. And then distribute it over here, and what do we get on that third term? X cubed y to the second power. That's right. And that's your answer. Is everybody with me? Yeah. Pretty easy, right? Of course, if you try to combine any of these, you can't because they're not like terms. Let's move on to the last one here, number 5. And let's distribute this monomial 4x squared to each of the terms on that trinomial on the inside of the parentheses. So 4x squared times 3x to the 5th. 4 times 3 is 12. X to the second times x to the 5th is x to the 7th. And then 4x squared times that negative 2. That's 4 times negative 2, negative 8, and then bring down the x squared with it. And then 4x squared times, this is really a 1x to the 3rd. What's 4x squared times 1x to the 3rd? Positive 4x to the 5th power. And that's it. That's your answer. But you could do something to make the answer look a little nicer, rearrange it in standard form from highest exponent down to smallest. So you'd have to take this one and move it over here, and take this one and move it right there. So switch places. So the final answer is 12x to the 7th plus 4x to the 5th minus 8x squared. That way it's organized in standard form. And your leading coefficient would be 12. Your degree would be 7. Just to review a couple of those vocab words from the previous section. Anyhow, this was all review, distributing. Now, today we're starting these new notes. And the title of the notes are called factoring. Okay? So let's start by understanding what factoring is. What is factoring? It's simply doing distributive property, but backwards. Okay? It's like having the answer and trying to find out the question. So there's many different forms of factoring that we're going to learn in this class. But the first one that we're going to cover today is pulling out the GCF. That's basic factoring, pulling out the GCF. Now, first of all, we need to know what GCF is, greatest common factor. So GCF is greatest common factor. Here it is, right? And what that means is you want to look at all of your terms in your polynomial and pull out what's in common in all the terms. Okay, and that's what it says here. Pull out any common multiple in all terms of the polynomial. All is underlined because it has to be in every single term in order for you to be able to pull out that GCF. So we have some examples. Right here we have a binomial, 8x minus 12. And what's in common in this first term and this second term? What's in common? Is there an x in this first term and an x in the second term? No. Is there the multiple of 2 in this first one and the multiple of 2 in the second one? Yeah, because 2 times 4 is 8 and 2 times 6 is 12. But is there a greater multiple? Because remember, this is the GCF that we want, the greatest common factor. So you want the greatest value that's in common in both terms. So 8 and 12, yes, the multiple of 2 is in common, but is there something greater? The multiple of what? 4. So I could technically take the binomial 8x minus 12 and put a 4 out here. So guys, if I pull out a 4, think about this. If I pull out a 4 from the 8x, what would I have left over? In other words, here's a 4 on the outside. 4 times what would get you that 8x? 2x, right? So in there you'd have a 2x, right? Now, if I did pull out a 4 from 12, in other words, 4 times what will get you this minus 12? A negative 3 or a minus 3. And that's what factoring is. Now, of course, on these notes, I already tell you how to do that. I actually give you the answer and the process. I say factor out a 4 because that's what's in common in this first term and the second term. And when you factor out a 4, you'll get this right here, and this is your factored form. And that's distributive property backwards. Because if you were to distribute 4 times 2x, you'll get 8x. 4 times 3, you'll get minus 12. And you get back to where you started from, 8x minus 12. Make sense? Okay, so again, we're factoring today. And what is factoring? It's doing distributive property backwards. It's kind of like having the answer and trying to find the question. So here's a second example. And we have x y to the 5th minus 6x y to the 7th plus 3y to the 2nd. Now, I already know that you guys could see the factored form right here. This is the answer, right? But let's pretend that you didn't see this. As a matter of fact, let me do this. Boom. Let's pretend you don't see it. Now, what do you have in the first term that's in common with the second term that's in common with the third term? Like right here you have a 3 and a 6. Could you pull out a 3 from here? No, you can't, right? There's only a coefficient of 1 right here. So actual numbers you can't pull out. But is there any letters that are in common in all 3 terms? Yeah, there's definitely y's in all 3 terms, right? So could I pull out 1 y from here, here, and here? Could I pull out 1 y from all of them? Yes, but would that be the greatest amount of y's? No. What's the greatest amount of y's that I could pull out from all 3 terms? It's okay if you give me the wrong answer. Okay, 7. Okay, so the question is, could we pull out 7 y's from the first term? No, there's only 5, huh? Okay. 2 is the greatest amount of y's that we could pull out. How many y's are here? 5. How many y's are here? 7. How many y's are here? 2. So what is the greatest amount of y's that you could pull out from all 3 of them at the same time? 2. Okay? So if we do pull out that 2, the y squared, the 2 y's, so you're going to have a y squared on the outside, you draw your parentheses, and then you see what's left over on the inside. So if I did take out y squared from this first term, if I took out 2 of the y's, then there would only be 3 y's left. If I took out 2 y's from the 7, then I'd only have 5 left. If I took out 2 y's from here, then I'd only have the 3 left. So as you can see, this is my factored form. If I were to distribute back in, I'd end up with what I originally started with. Okay? So these are all examples. We haven't even tried any yet. You're just seeing how I've been doing these. Let's look at number 3 here. Okay, so number 3, here's another example. I have 8x to the third, a minus 16x to the fifth, I have a 12x to the second. Now, do I have any numbers in common in all 3 terms? Do I have numbers in the coefficients that are in common? Like, is there an 8 here? Yes. Is there an 8 here, a multiple of 8? Yes. Is there a multiple of 8 here? No. Okay, so it's not 8, but what could you pull out of all those numbers? You can pull out a 2, but that's not the greatest. The greatest is 4, right? I mean, you could already see that because I give you the factored form answer right here. But when you think about 8, 16, and 12, you could pull out the multiple of 4 in each of these, all right? And not only could you pull out the multiple of 4, but you could also pull out, there's something else in common. There's x's. There's 3x's here, 5x's here, 2x's here. So you could also pull out a maximum amount of x's. And what's that maximum amount of x's that you could pull out? 2. So the GCF, including the numbers and the letters, is 4x squared. That's our GCF. The GCF is 4x squared. So if I pull out the 4x squared, what will I have left over on the inside? Well, if I pull out a 4 from here, it's like saying 4x squared times what will get us back to the 8x to the third? Or 4x squared times 2 will get us to 8, and x squared times x will get us to x to the third. 4 times what will give us a minus 16? 4 times minus 4. So that's how we come up with this stuff. X squared times x to the third will get us the x to the fifth. Okay, so it's kind of like doing distributive property backwards. Now, seeing the answers right there is not going to help you. We actually have to work through these so you could actually get better at this. So let's look at this 4th example. Right here in this 4th example, we have 3 terms, 1, 2, 3. Is there x's in all 3 terms? No, I have x to the third, I have x to the fifth. Do I have any x's here? No, I do not. Do I have coefficients that I could pull out? Here's a 2, here's a 4. Is that a 6? No, it's a 5. So it's not even an even number. I can't even pull out 2, right? So I can't pull out a number. I can't pull out letters. So what do I do, or what do I say? Right here, if we read along right here, it says all three third. What? Sorry. What it says right here is all 3 terms have nothing in common. You are not able to factor it. So when you're not able to factor it, you say not factorable, not factorable. Okay, when you're not able to factor it, you say not factorable. Okay, so that's your answer. If I tell you factor this and you can't really factor anything, you just say not factorable. Okay, so here are some practice problems that I want you guys to look at. So let's take a look at number 1 here. What's in common in both terms? What is the GCF that I could pull out of both terms at the same time? 7. So if I do pull out a 7, what would be left on the inside? X. And 7, but of course I need a plus sign right there, right? Okay. And how about this next one? Number 2, we have a 10q, you're welcome, minus 25q squared. What's in common in both terms? There's 5s and there's what? There's q's, right? So I could definitely pull out the multiple of 5, and I could definitely pull out one of those q's. That's my maximum amount of q's. So if I do pull out the 5q, what would be left on this first term? If I pull out a 5q, what's left in here? In other words, check this out. Check this out. Remember, it's reverse distributive property. In other words, 5q times what?
2.
Will give me the 10q. 2. So 5q times 2 will give me this above first term, 10q. There you go. And then 5q times what will get you this negative 25q squared? That is a negative 5q. But you can't use it as a joke right there because 5q doesn't sound like thank you. Okay. But do you guys understand here?
Yeah.
Factoring out the GCF? Okay. It's easy, but it's all, this is like the very first step of the ladder. Very first step of the ladder. If you understand this first step and you're able to do it, that's great. You're standing on the first step, and it'll be really easy to get to the next step and the next step. There's like 8,000 steps on this ladder. How about number 3? What's in common right there?
8.
There's an 8
8.
and there's an A. Okay, so looking at the numbers, the coefficient, there's a number 8 and there's a number negative 56. What could you pull out of there on those numbers? You could pull out an 8. And you could also pull out, there's an A here and an A there, so you could pull out an A. So the greatest common factor is 8A. Now see, if you just say I'm going to pull out an 8, yeah, you can pull out an 8, but that's not the GCF. It's not the greatest common factor. And if you just say, oh, there's A, you can pull out an A. Yeah, you can pull out an A, but that's not the greatest. The greatest is to pull out an 8 and an A. Pull out that 8A. Now, if you do pull out an 8A, what would be left? In other words, 8A times what will get you back to this first term? 1x, that's right. Now we can just write it as x, right? And then how about over here, 8A times what, Ismail, will get us a negative 56A? Just 7? Yeah, negative 7 or minus 7, right? And that's it. Okay, let's move on. How about number 4? We have 3 terms right here. And you got to ask yourself, what's in common? Now, there is no coefficients. There's no number here, no number here, no number there. So forget about the numbers, but there are letters in common. What is the maximum amount of letters we could pull out of all 3 terms at the same time? 1x. And 1y? Let's see. Just 1x. You see how there's an x here? There's 2 x's here. There's 3 x's here. The maximum amount of x's that we could pull out of all 3 terms at the same time, maximum amount of x's is just one of those x's, right? Now, if you're thinking y's, well, I have a y here, I have a y here. Do I have a y in the first term? No. So you can't pull out a y. Again, the only thing you could pull out is what's in common in all of the terms. Has to be every single term that you pull out, okay? So if I did pull out an x from the first term, what's going to be left? In other words, x times what gives us a first term x? X times what gives us a first term x? There you go, positive 1, right? Now, how about this? X times what gives us a second term x squared y? Plus x y, right? Because x times xy gives you the x squared y. And then x times what gives you this third term? Plus x to the second power, but will x times x to the second give you x to the third and y to the second? No. So what's it missing down here? Y to the second. And that's your factored form right there. Make sense? Now, the last one, number 5, what's in common right there? Like if you say 2, yes, 2 is in common, but there's something greater than 2, 4, right? If you say 4 is the greatest common factor, it's not the greatest common factor. It's a factor that you could pull out, but it's not the greatest thing that's in common in all 3 terms. What is the greatest thing that's in common in all 3 terms? 4 and what? There's something else that belongs with the 4. X. But how many x's?
2.
Squared. So our GCF, you can't just say 4. You can't just say x. You can't just say x squared. You have to say 4x squared. So your GCF is 4x squared. Now, what would be left on the inside of the parentheses if you did pull out a 4x squared? And once again, let me reiterate this. 4x squared times what gives you 12x to the 7th? Okay. 3x to the 5th power. Because when you multiply the exponents, they get added, right? Now, if I take 4x squared and multiply it by what in the middle will give me this middle term? Right there, we just need let's think about this one more time. 4x squared times what? 4 times what gives you a negative 8? 4 times negative 2 gives you a negative 8. But of course, the x squared is going to, whoa, I'm sorry. Why is this wrong? Because if I were to multiply 4x squared times 2x squared, it does not give me negative 8x to the second. It would give me to the 4th. So I need to erase that. Okay, now for the final term, 4x squared times what gives us 4x to the fifth? Positive 1x cubed. And we don't even need the 1 if you don't want it. What do you guys think? Now check this out, guys. I don't know if you noticed, but the class opener questions that I did up here were the exact questions that we just did, but backwards. So if you look at the class opener question number 1, where we distributed 7 times x, 7 times 7, we got 7x plus 49. Down here, I took that answer, 7x plus 49, and I asked you to factor, to do it backwards. And you got back to the 7 parentheses times x plus 7. So, as you can see, each of these corresponds to the class opener questions to reinforce that factoring is simply doing distributive property backwards. It's like having the answer and finding the question. So I'm going to stop right here, and I'm going to pick up the next video on this special situation. What if they asked you to factor this, and you're trying to pull out the GCF, but, oh, there's a 2 in common. There's a 2 in common, but there's no 2 here, and there's no 2 here. Or maybe you're thinking x's, but there's no x on the last one. Now, some of us are going to say that it's not factorable, but there's a new method that we're going to learn on the next video that'll teach you how to factor this nasty looking polynomial. But we will pick that up on the next video, not right now.